In this video, we're going to go over basically how to move from one form to another. So far, what we've done is we've gone from the standard form, which is y equals ax squared plus bx plus c, to the factored form, which is y equals ax minus bx minus q. So in other words, we've basically gone from this direction to the other. So what we're going to learn today, or sort of even in this video, is how to go in the opposite direction. And it's actually quite straightforward, and you've already done this, a little bit of this something before, so let me just show you an example and to make it clear. So say, for example, we have something in factored form, which is y is equal to 3x minus 1, x plus 4. So this is in factored form, and now we want to get into standard form. So in order to do that, what I can do is I can just leave the 3 out there and I can expand these two. So using FOIL, it's the first term times the last term, so that's x squared. The first term times the last term over there, which is plus 4x. The second term times the first term, so that's negative 1x. And the second term here times the last term there, which is negative 4. And if I simplify this, this is x squared plus 3x minus 4. And let me just go here. So that's, oops, I don't need that. And so finally, what I can do is I can distribute the 3 amongst the 3 terms over here. So it's 3x squared plus 9x minus 12, and there you have it. I have the standard form. So really what we've done is we have gone from the factored form, which is this right here, and all the way to the standard form, which is that over there. Okay? So let's actually do a much more interesting example of going from the factored form to the standard form. So let's look at this question right here and try to solve it. So the function y equals x squared plus px plus q is shown below. So that's basically the graph below. With the x-intercepts negative 3, so here's negative 3, and 4, which is 4 over here. So these are our x-intercepts, which I'm sort of re-highlighting in red. Okay, find the values of p and q. Now, if we take a look at this, so this is y equals x squared plus px plus q. Now, traditionally, what I've done in the other examples, I've said that p and q are the x-intercepts. Now, let's take a look at the previous slide and see what that is. So here, I said that p was the x-intercept and q was the x-intercept. But really, I could have labeled it any other different way. So say, for example, I wanted to label it as y equals a, x minus b, x minus c. So in this case, b and c are the x-intercepts. I could have called it e and f, g and h, I and j. It doesn't really matter what you call them, but they stand for the x-intercept. So I just call them p and q just because those were the letters that I liked, but it really doesn't matter. So you need to really pay attention to what form it is and what we're really looking for. So similarly, even with the standard form, I could have said this is a equals ex squared plus fx plus ef plus g. So in this case, e would have been our vertical stretch, and g would have been our constant, so in other words, our y-intercept. So it doesn't really matter what you call them, as long as you understand what form they're in and what they actually mean. So going back to this here, p and q no longer stand for the x and y intercepts. What they stand for in this case is basically the components in the standard form. So let's figure that out. So, and one thing you should observe is that in this form, they've actually given us one clue. They've said that this is x squared. In other words, the vertical stretch is just basically 1. So let me write this in standard form. Let me use green here. So y equals a x minus b and x minus c. I'm using b and c now because I don't want to confuse it with p and q. So what is a? Well, from the standard form over here, we've observed that this is the vertical stretch. So basically a is equal to 1. Now b and c stand for the x-intercepts. So we have one x-intercept, which is negative 3. So it's x minus, maybe I'll put this in yellow, negative 3. And this is going to be x minus, and that's simply going to be 4. So if I simplify this, this is going to be 1 times, and now x minus negative 3, so that's x plus 3, and this is simply x minus 4. So here what we have is the standard form, and what we're looking for is the, here what we have is the factored form, and what we're looking for is the standard form. So how do I go from the factored form to the standard form? Well, I just have to expand this. So let me expand that. So I get 1, here it's x squared. The first term times this first term here, x squared. So minus 4x plus 3x minus 12. And this is going to be, so 1 times everything there. So it's x squared minus x minus 12. So if we're looking for, let's look, what we're looking for is x squared plus px plus q. Then basically the p over here will correspond to the -1 that we see over here, and the q over here will correspond to the constant that we see over here. So therefore, p is equal to -1 because this p is basically that over there, and q will correspond to the constant, so q is equal to -12, and therefore we have our solution. So therefore what we can do is, for this problem, we've pretty much gone from the factored form and expanded it to the standard form and determined what our values of p and q are. And recall that p and q in this instance is not the they're not the x-intercepts. They're basically whatever coefficients they are for the standard form. All right, so I'll see you in the next video.